Hi, in this tutorial, we'll move to infrared.city connector in Grasshopper. We'll go through a basic workflow to get you started, and in the upcoming videos, we'll raise the bar to more advanced workflows you can integrate in your design process. You can download infrared.city plugin through the package manager. Install the latest version and restart Rhino. I have it ready in my Grasshopper. On the tab, you'll see three sections, one for managing project, one for managing and adding analysis. More will be added soon, so keep your infrared city plugin up to date. And another tab for running simulations. From the latest tutorial, we were working on a tower on the web. Now I have modeled more detailed massings to test in my design environment here in Rhino. I have added three design options that I'd like to test. To start, I'll need to log into my account. To do so, I'll go to Account and then Log in. By clicking Login, I will be redirected on the web to enter my credentials. Once I'm in, I'll need to access my project. For that, again, under Account, I'll drop the Load Project component. You have either the option to create a new project. For that, you'll be redirected on the web, and you can follow the first tutorial to know how to create a new project. Or, as in my case, load a project you have already created. I need the latest for skyscraper in Vienna. Loading a project will drop two elements on the canvas, one containing the existing analysis setup and another containing the existing geometry. Generally, this will be the urban context. I can use parametric methods to make any changes to the context geometry, or bake it in a separate layer and reference it again. To allow smooth updates of the project and maintain the separation between project states, both the geometry and the analysis components are delivered as internalized data. Meaning that once the baked and modified context is referenced to another component, the previously generated geometry component can be deleted. To create a continuous updated connection between my design layers and the analysis workflow, I will connect the design to my script using the geometry pipeline component. Of course, any method for generating or referencing geometry can be used as needed. I can double-click on the type of geometry and select the design by layer's name. For instance, I'll start with Tower 1. To run the analysis, I will need to update the new elements of the project, the tower's geometry in this case, and remember to include the context geometry. To update the project with the new information, I'll go to the first tab and select Update. infrared.city accepts triangulated meshes as geometry input. So it is important that if my geometry is a B-rep or a sub-D, to make sure my geometry is a triangulated mesh to ensure the analysis is performed correctly. For this, I will add a B-rep to mesh component and follow with a triangulate mesh component, both standard components in Grasshopper. In this component, I'll plug in the project and the geometry. You can press the Update button on the component or plug a button input in the update parameter. At right-click, you also have the Auto Update option, but we will look at this in detail in a later tutorial. Now it's all ready to run the simulation. There are two ways to run your simulation. One is through the Run Simulation Thing component, which is meant for use with the Auto Update option in automatic workflows. This component will compute synchronously and will update your canvas after it's computed, so you'll have to wait for it to compute before you can make more changes. To visualize the results, use the Display Results component. You can visualize both the mesh and the values result. You can use a filter here or other methods to isolate critical areas or use conditional formulas to compute design performance. Now we can go back and select the other two massings to compare and make our design conclusions on the best design option we have so far. We can also add more simulation and run async to get all our results at once to compare. You can add a method to record performance data to your script and share the setup with your team to empower everyone to make informed iterations. Again, simple and fast.